Alright, hi, I'm Sebastian Ma, and we're going to do solids of revolution and cross sections today. So, the first thing we're going to do is we're going to talk about cross section. We're going to do both the x and the y axes, one problem of each. So, what I'm going to do here is I'm going to draw a graph right here, x axis, y axis, and what I'm actually want to do is I want to make this problem go a little bit into the negative, because what I want to do is I'm going to make the axes of revolution -1, right? This is -1. I actually want to make this a different color. I want to make this blue, right? So we know this is the axes of revolution. And then what I'm also going to do is I want to make the f of x equation. There we go, f of x. F of x equals x. F of x equals x. And the second equation will be green. G of x will be x squared. Okay, now for solids of revolution, you have two new ideas, right? They're actually they're the same, really. It's big R and little r. Big R is the one furthest away from the solids of revolution. So it's the equation that has the most distance from the axes of rotation. And little r, similarly, is the one with less distance between the axes of rotation and the equation. And how you incorporate this into the equation, as you should know, the equation is b equals pi integral b of a, b to a, r squared, big R squared, minus little r squared, okay? I'm actually cutting it close there. But that is the equation. And now what we have here is big R, as we know, is f of x. But how do you incorporate that -1, the axis of rotation, into these r's? What we have here is r equals f of x minus the distance of the axis of rotation, in this case, is -1. So I'm actually want to fill this out right here. How to use this eraser. Instead of f of x, I will write in the equation right now, which is x minus -1. I do put it in parentheses because equations do change and it could become tricky. Similarly, little r is r equals g of x, but I will write down the equation, x squared minus -1. Alright, and I will fill this out on the next page. We have v equals pi integral. Oh yeah, and I didn't talk about integrals. Integrals, as you know from the previous segment of area under the curve, right now we want to just use this point right here and this point right here. We'll actually make it different colors again. Let's do orange right now, right here to here. Why? Because they're intersecting at those 2 points. Of course, the question can always change. Look out for the question, but for right now, we want to use this point of intersection, which is 0, 0, and this point of intersection, which is 1, 1. Alright? And because we're rotating around a horizontal axis, similarly to the x-axis, you'll be using the x-coordinate. If you were doing it around a y-axis or a vertical axis, it would be around the y-coordinates. So right now they are the same, so it really doesn't make too much of a difference, but just know we'll be using the x-coordinates right now, right? So in the next page, I will be doing this. I actually kind of want to fill this out here. B, A, just so you know what's going on. R, and R, right? I'm sure you already understand, but... And so, the coordinates right now will be the higher coordinate to the lower coordinate, as you already know. And just want to follow suit with the colors. Keep it as coordinated as I can right now. And I'm actually going to need a lot more space for this. So I'm actually going to bring all this into the next line below. It's going to be slightly long. We have big R right here. Big R, this equation, just plug that in. So I can actually do this. Here. Make this red. X minus -1. I probably didn't need this one right here. Right. X minus -1 minus and I'll square this. X squared minus -1. And then you'll be squaring this as well. Because this whole entire thing right here is big R. And this whole entire thing right here is little r. Okay? Whoops. Wrong color. So you will need to square the whole entire thing. Alright? And now I'm going to kind of skip ahead here and quickly simplify these two before I do the integral. Alright, so I finished simplifying the equation. It was all algebra. There was no calculus involved. So that was not necessary to show. But now that I have the equation, I now need to take the integral of it, which I will do in the next page, which I have already set up the equation with. Oh, my bad. Let's do this. Nothing much, just OCD. And now I will take the integral of this equation, which would be v equals pi integrand. No, actually, it's no longer integrand, but you now use a line because I have already taken the integral of this formula. Now x to the 5th over 5 minus x to the 3rd over 3 plus, it would be 2x squared over 2, so we can just say x squared, right? That is the integral. And now what you have to do is you merely plug in the numbers that you have from this, right? The 1 and the 0. Right? So you would, I am going to show the 0, but it is unnecessary because you would be subtracting it away. I will show you what I mean in just a second. I will also do this on the next screen. I have already taken care of writing it down. I did not want to waste too much time, so I went ahead and did that. So as you can see, I put in the numbers, the 1 and the 0, as you can see. I plug them in. You subtract the top number from the bottom integrand, the 1 and the 0, and I plug them in. Now, as I was talking about earlier, you can actually cross out these zeros, because obviously these all equal 0, and they don't make much of a difference in this equation, which leaves you with v equals pi times, now you don't even have integrand anymore or anything like that. You literally just have this 1 over 5 minus 1 over 3 plus 1, right? And then you simplify this, which simplifying this should give you, just do it real quick right here, 1/5, 1/3, plus 1. You find a common denominator, you get v equals pi. I'm pretty sure it's 15 is the common denominator, so 3 over 15 minus 5 over 15 plus 15 over 15, right? V equals 15. You get 15 over 15 minus 8 over 15, right? Simplify this, and V equals 15 minus 8, which equals 7 pi over 15. And that is your result. So, real quickly, rundown, right? Right here, you graph it, you find the axes of revolution, you know f of x's, you know g of x's, you find a big R and a little r, very important. You find your integrand coordinates, in this case it was 1 to 0, and then you plug in big R and little r. You you write down the formula, you plug in the numbers, you simplify the equation. After you simplify the equation, you take the integral, you plug the integrand numbers in, and then you simplify the equation once again, and you get the answer, right? So, I'm going to do one more solids of revolution.